This is part 4 of our basic chemistry lecture. So in this final part, we're going to discuss the importance of carbon. Now, we will hit this topic really hard in chapter 3, but I just want to give you all a basic introduction to the importance of carbon in living systems. So we know that water is the universal medium for all life. We just saw the importance of water and all of its special compounds due to its polar nature. But life and the molecules of life are all said to be organic compounds. Now, these are compounds that contain lots of covalently bonded carbon. So remember, a covalent bond is a bond where electrons are shared. Now, these organic compounds are things like sugars and proteins and fats and even DNA. Don't get them confused with inorganic compounds such as sodium chloride, right? Now, these organic compounds are unique in their properties. They're different. Different organic compounds are able to do different things based upon some properties we'll talk about in just a moment. But we also have a category of organic compounds called hydrocarbons. And now these are organic molecules that only have lots of carbon and hydrogen to them. These hydrocarbons, and anytime we have all of these covalently bonded carbon atoms, we have lots of stored energy, right? So if you think back a moment to what covalent bonds are, those shared electrons, there's an energy value there. And as we break those covalent bonds, we're going to see some of that energy that can be liberated. Now, we'll talk more about this in the third unit, but ATP, adenosine triphosphate, this is a very important organic compound that's actually the energy currency of the cell. And as you'll see, by breaking a covalent bond and removing one of these three phosphates from ATP to make adenosine diphosphate, or ADP, we're going to liberate a lot of energy for the cell to use to do its work. Now, the properties of these organic molecules depend upon the arrangement of the carbon skeleton and the kinds of other molecular attachments that we may find there. So just to give you an example, here's a carbon skeleton. You can see the carbon atoms and these hydrogens bonded to them. So these would be examples of hydrocarbons. Notice that in this example here we see a double covalent bond. Now, carbon likes to have 8 electrons in its valence shell, and carbon atoms can form 4 covalent bonds as they are sharing 4 electrons with other things. Okay, so the first property of an organic molecule that can determine its function is the carbon skeleton, how we arrange these carbons and these hydrogens together. Now, the second property is determined by the functional groups that we put on the carbon skeleton. Sometimes the functional groups are just additional carbons and hydrogens. Sometimes they might be oxygens or hydroxides. But the functional groups that we stick on the carbon skeleton give it some very unique properties. And again, the properties determine shapes, and shapes often determine functions. So in this example here, we see what's a very simple looking set of molecules. In fact, if we look at the basic shape of this set of molecules and this molecule, they look very, very similar. The only real difference is here we have a hydroxide and here we have a double bonded oxygen and an additional carbon atom with 3 hydrogens around it. Yet these very subtle differences give these molecules some very, very, very unique properties. So this molecule is a molecule called estrogen, and this molecule is a molecule called testosterone. Obviously, estrogen and testosterone do some very different things in an animal's body, helping to promote the gender and sex differences. A couple of things I want to point out to you all that I wish somebody had pointed out to me before I had organic chemistry. We often see organic molecules or carbon-based molecules depicted in these structural diagrams like this, and you see a carbon here, but what kinds of molecules are here? Well, it's understood that everywhere we have one of these lines that comes together, we have a carbon. And so remember, if there's a carbon here and a carbon here, then we also have two hydrogens on either side, right? So that was often difficult for me to kind of visualize. But the way that these carbon atoms bond covalently together, they're able to form these rings or these five-sided structures like this. And again, it's the shape of that carbon skeleton and the functional groups that are stuck on it that help to determine their properties. So that wraps up our unit on basic chemistry.